So to finish off this volumetric analysis series, I just want to talk briefly about precision and accuracy, because this is one of the most likely places a question about precision, accuracy, and random and systematic errors are likely to come up. It'll also hopefully help you when you do the evaluation for your practical report. And as I've said, we will do a summative practical on doing a titration. That'll be one of our 2 summative practicals for the year. So precision is related to the scatter in our data. So whether our results are all really close together or whether they're spread out all over the place. Low precision means a high level of scatter, lots of scatter. High precision means a very low level of scatter, so not very much scatter. The main cause of a lack of precision, the main cause of a lack of precision is random errors. So they are the measurement or judgment uncertainties in an experiment. So is your eye level with the meniscus when you're measuring it? Did you get the colour point? Did you get the end point the same in every case? Is that shade of colour that's changed with the indicator changed to the same shade in every case? When you have delivered from your pipette, have you done that in a consistent way? And have you sort of got rid of that last drop in the same way each time, so you're not getting slightly varying volumes from problems with your measurement or your experimental technique, the repeatability of that technique. So accuracy is about how close we are to the true value or the known value. A low accuracy will be not close to the true value, so you haven't got a very good answer. High accuracy means you're very close to the true value, so the correct value for that experiment. And the thing that mostly affects accuracy is systematic errors, and that can be due to incorrectly calibrated or faulty equipment, or in a titration it can also be due to impure reagents. So if your standard solution is supposed to be 1 mole per litre, but it's not 1 mole per litre because there's an impurity there, you're never actually going to get the right result. So let's just see how this might look in an experiment. Let's say 4 students completed a titration. The true value was known to be 30 millilitres. And we have got the 4 students' results here. So let's just have a look at each of these students' results. So firstly, this student got results of 31.5, 31.4, 31.5. So they're all within 0.1 millilitres of each other. We talked about that before. We would say they're concordant titers. So we would give this person a big tick for their precision. I might use a bigger arrow. A big tick. However, the true value was supposed to be 30.0 and they're at 31.5. So they're 1.5 millilitres off the true value. So we're going to say they're not very accurate. Let's have a look at this student here. 28.2, 30.0, 31.8. So that's a lot of scatter. They are well past within 0.1 mil. They're sort of all within, from top to bottom, there's almost 4 mil. So this person here was not very precise. However, maybe they were just lucky, who knows, their average result came out spot on the true value. So we could say that is an accurate result. So I'd tend to say they just got lucky, because poor precision is usually showing poor technique, but they've just happened to have got the right answer. We'll now look at student C. Once again, this student 27.6, 31.2, 28.1. So we would say precision, not good. They're all over the place, well past 0.1 mil from each other. So they get a cross, no good for precision. And their average is 29 from those numbers. So they're still 1 mil off. So we're going to say not very accurate. And finally, we have this student here, 30.1, 30.0, 30.0. Those numbers average out to 30.0 if we just take three significant figures. Precision, very good, all within 0.1 mil, very close to the true value. So this student would be both precise and accurate. They would have very little random error, or they would have very little systematic error. So that's just a bit of an overview of precision and accuracy. You will need to explore the reasons for this more, particularly when you do an evaluation in a prac, but this sort of level that I've just discussed will probably get you through most test and exam questions. Thank you.